Well, hello again, Year 12. Today we're learning about error in measurement. Now, we've been doing some work on measurement, and you know that whenever you measure something, that you could probably have measured it a little bit more accurately than what you actually wrote down. So having a look at the pencil that we've got on the screen here, it looks to be about 4 centimetres long. But is that an accurate measurement? So let's have a look. It looks like 4 centimetres, but if we look really closely, we can see that, well, we could have actually said it was 4.2 centimetres. But what we write down depends on how accurately we are measuring. So there's often an error in measurement depending on what unit we're going to be looking at. And the definition of this error is the difference between the measured value that you decide on and the true value. So let's move on a little bit and go into some definitions of error. So the absolute error is the largest possible error that you can get when you're measuring something. And we have a definition for this that you'll need to write down. And that's plus or minus half the smallest unit of measurement. So write that one down. So our pencil, we measured at 4 centimetres, but we were only really doing that accurate to the nearest centimetre. So it was 4 centimetres to the nearest centimetre. So the absolute error is plus or minus a half a centimetre. Now we generally write that as a decimal, so we would write that as plus or minus 0.5 centimetres. So that is the absolute error. That means that it could be, our measurement could be half a centimetre too big, or it could be half a centimetre too small. Our next definition, percentage error. Now this tells us really how important the error is. So we have a definition of the error, the percentage error. So that's absolute error. So write this down. Absolute error over the measurement that you've taken, the measured value, and then to make it a percentage times 100. So if we look at the pencil that we just measured there, the absolute error, now we said that that could be plus or minus half a centimetre. The pencil itself was 4 centimetres, and then we're going to multiply that by 100. So that will give us the percentage error for that particular item that we measured. So we've got the absolute error as plus or minus 0.5, but when we're doing the actual calculation, we only really need to calculate with the positive value. So 0.5 divided by 4 multiplied by 100 is 12.5. So that's 12.5%. That's our percentage error. Now 12.5 is a pretty big error. So that's actually 1/8. So if your measurement is, 1/8 of the measurement could be an error, then that's really not a good error. It's good to keep errors down to less than about 2%. So when you measure something like a pencil, you really should be going to the nearest millimetre rather than the nearest centimetre. Now, the last definition that we're looking at is limits of accuracy. This is very useful because it shows us the range of possible values for a measurement. So, back to our pencil again, we measured it at 4 centimetres, but we know that it could have been plus half a centimetre, or it could have been 4 centimetres minus half a centimetre. So looking at those two values, it could be 3.5 centimetres. This is the lower limit. So the smallest that the pencil could be is 3.5 centimetres, or the largest that it could have been, based on our measurement, is 4.5 centimetres. So this one we call the upper limit. So the possible measurements for our pencil could be anywhere between 3.5 and 4.5 centimetres, and we write that as 4 centimetres plus or minus 0.5 centimetres. The plus or minus means that it could be either of those. Now let's have a look at some other examples. So a dog, first of all, the mass of a dog. So we've put the dog on the scales and it's weighed in at 25 kilograms. Now that's just to the nearest kilogram. So we know that there's probably an error there, that it probably wasn't exactly 25 kilos, but to the nearest kilo it was 25. So the absolute error, we need to look at the smallest measurement, which was nearest kilos. So plus or minus a half a kilo is the absolute error. Percentage error, we have to use our formula. So if you remember back to what the formula was, the formula is absolute error over the measurement times 100. So we'll sub in what we know, and so the two numbers that we know are the absolute error is 0.5, the total measurement is 25, and then times 100. So we'll do the calculation for that as well and see how that compares to our pencil. Right, so that calculates out at 2. So 2%. So the 2% is our percentage error for the dog, and that's much less than the error that we had for that pencil. So the measurement of 25 kilos is a much more accurate measurement for this dog than the 4 centimetres was for our pencil. So that way we can compare. Here's another example. It's a car and it's been measured at 6.2 metres to the nearest 10 centimetres. Now we have to be careful here because we've got mixed units. We've got metres and we've got centimetres, but we need to remember also that anything after the decimal point in metres is going to be in centimetres or sometimes in millimetres. So the absolute measurement is half the smallest unit. This time the smallest unit is 10 centimetres, so the absolute error is going to be plus or minus 5 centimetres. Percentage area, we just plug those numbers into the formula again. So again, percentage error is going to be the absolute error over the measurement times 100. So subbing the numbers into there, the absolute error is 5 centimetres, and we have to be careful with our mixed units here. The measurement itself is 6.2 metres, so we better write that in centimetres. So 100 centimetres in a metre, so we'll multiply by 100 and we'll end up with 620 centimetres. So 620 centimetres, we'll use that in our calculation and then times 100. And let's see how significant this error is. Okay, so we've got 0.86, so 0.80645. 80645. So that is less than 1%. So this is our least important error, our least significant error. So we had the pencil that had a large error. We had the dog that had a respectable error. 2% is quite respectable, but this, the car being measured to the nearest 10 centimetres, less than 1% error, so that's quite an accurate measurement. So I'm hoping that you're getting some sense of how there's different levels of error in a measurement. So our final question, which measurement, the car or the dog, is most accurate and why? Hopefully you have chosen the car. The car is the most accurate because the percentage error was the lowest. So it had a very low percentage error. In fact, it was less than 1%, which indicates that it is a very accurate measurement. And that ends this video on error of measurement. Thank you for listening to my first ever video that I've made for teaching.